Good evening, ladies and gents. In this video, I will be showing you how to display distributions graphically. There are three main types of graphs that you will use for quantitative data. They are a stem and leaf plot, we'll just call them stem plots, a histogram, and a box and whisker plot, or a box plot. Now I'm going to make a separate video for each one of these, so they'll just be kind of a continuation of each other. My advice would be to take some time to pause throughout the videos and write things down, because I'm going to go faster, and sometimes making the graphs takes a second. So again, feel free to pause and copy some things down. So in the last chapter we talked about collecting data, and we made a big deal about the multiple ways that you can collect data. And so we've collected data. We went through our steps, our randomization and whatnot, and what we have here are the AP student pulse rates in beats per minute. If you remember, towards the beginning of school, we all sat down and figured out our pulse rate. So I have here the pulse rates of 35 AP students measured in beats per minute. Now, when you get a data set like this, it's going to be helpful for graphing or displaying graphically if they're in order. So the first thing you're going to want to do is put these in order. So take a second to pause, write these numbers down, and write them down in order. Now you can do that a couple different ways. My favorite way is I just kind of go and I scan and I try to find the shortest number and I cross them off as I go. That way, by crossing them off, I don't repeat any numbers or I don't miss any numbers. So I look here, I see 42 is the smallest number, so I'm going to go ahead and write that down. And then I scan through here to see numbers greater than 42. I see a 46, but I keep going to make sure, there's no numbers that are larger than that. 46 appears to be the next biggest number. There's no other 46s, so 47, and on and on and on and on. Now, I've got this lovely smartboard that's already got it done for me. So there are the numbers in order, and we will be using those numbers for the three types of graphs. So first one we're going to talk about is a stem plot. Most of you have some sort of prior knowledge of what a stem and leaf plot is. You basically have the stem, which is all the digits, but the leaf, which is the last digit. So the stem is all the digits before the last digit. Some examples would be 32. You would write it as 3, 2. 2.9 would look like 2, 9. 112 might look like 11, and then a 2. So there's some examples of that. Now, I have my data here, same data as before the pulse rates, and they're in order, which again you will see becomes very helpful with this. And again, the idea behind this is this list of numbers that I see right now isn't enough. I can't really tell what's going on. I see the low number, I see the high number. I can't really tell what the data looks like, what the distribution looks like. So I need a visual model. So the first thing I'm going to do is I'm going to draw a bar. That'll kind of separate my stems and leaves. I'm going to label it or title the graph AP pulse rates measured in beats per minute. All right, that's key to have a title to your graph. Now, I look at the numbers, and the numbers go from 40 to 50 to 60 to 70 to 80. So those are basically going to be my stems. 4, 5, 6, 7, 8. Again, in my stem plot, I want the numbers to be in order. So it's helpful that my numbers are already in order. I look over here, I got 42, and again, I'll cross them out. 6, 7, 42, 6, 7, 8, 9, 8, 9. So there's all the 40s. Continue on with the 50s. 0, 2, 4, 4, 6. 0, 2, 4, 4, 6. 6, 6, 8, 9. We're to the 60s. 0, 1, 1, 2, 3. 0, 1, 1, 2, 3. 5, 5, 5. And again, I'm doing this so I don't miss anything. 7, 8, 8, 9. 8, 8, 9. 0, 0, 1, 1. Sounds like binary code. Whoops. 0, 0, 1, 1. 4, 8. And as I'm doing this, I'm trying to make my digits cover about the same amount of space, so it's all to scale. 0, 1, 5. And here, I'm missing one last thing. I need a key. So if any random wants to come along and read my graph, they can tell what the numbers stand for. So 5, 2 equals 52. So there's my key there. So from this, now I have a better idea of what the data looks like. Most of the numbers were in the 60s. As the less and less people as the beats per minute got higher, and less people as they got lower as well. Now, I'm going to go off on a side note here. Sometimes if you're looking at this and you have a few amount of stems, there's 5 here, that's not too bad, but there's a lot of numbers here in the 6, and sometimes there's just, the data's all too close together, so you can do what's called a split stem. Split stem, and it gives you a better idea. So I'll do a quick version of the split stem. What you're going to do is draw your bar, and you're going to separate every stem basically into 2. So there's going to be 2 4s, 2 5s, 2 6s, 2 7s, and 2 8s. Bring this down a little bit. And then the digits are split into 0 to 4 and 5 to 9. So I'm recreating the same data, it's just going to be split a little bit. So 2 and then 6, 7, 8, 9. Here. 2 and 6, 7, 8, 9. So 2 will go in the first one, and 6, 7, 8, 9 will go in the second. The 5s are 0, 2, 4, 4. 0, 2, 4, 4. And 6, 6, 6. There it is again. 8, 9. 6, 6, 6, 8, 9. The 6s are 0, 1, 1, 2, 3. 0, 1, 1, 2, 3. And 5, 5, 5, 7, 8, 8, 9. 5, 5, 5, 7, 8, 8, 9. The 7s are split into 2 zeros, 2 1s, and a 4. 0, 0, 1, 1, that binary code. 8, 9, I believe. Just a 9. Or just an 8. And then your 8s are 0, 1, and 5. And again, it gives us a little bit better idea. It spreads the graph out a little bit so that any one of the pillars aren't so tall. That's a stem and leaf plot.